Hello, welcome to this video. In this video, we are going to look at a 2022 paper 2 GCE Science internal. Not GCE, but Science internal. Yes, internal. Paper 2, which is chemistry. So, and we are going to look at section B. We are only going to concentrate on the question number 1, the B1. It says, A1, give one reason why laboratory rules are very important. Why are laboratory rules very important? All right. Of course, you can come up with a lot of reasons, but they just want you to give one. So one of the reasons why laboratory rules are important is that they ensure that there is safety in the lab. So they ensure safety. Okay, in the what? In the lab. By preventing accidents, okay, injuries. Simple, 1 mark. Okay, state one importance of chemistry in our day-to-day life. The importance of chemistry, there are a lot. You can also put junta. Since you junta, you can put junta there. It is as a result of chemistry, you know. But now one of the importance of chemistry in our day-to-day life is that it is important in the manufacturing of products. Okay, so it is important. Okay, in the what? In the manufacturing of products. You know products, right? Like tumafuta, for example, medicines. Okay, cleaning agents. There are quite a lot, guys. etc. So you can. There are quite a number of the importance of chemistry. There are a lot, like there are a lot. Okay. Next is that the following graphs show heating caves that were drawn after pure ice, so ice and candle wax were heated over time to their melting point. So we have pure ice and candle wax being heated. So we don't know which one is for a candle, we don't know which one is for pure ice, but we've got X and Y. Identify the heating cave for the candle wax and give a reason for your answer. Which heating cave here is for a candle wax, guys? Which one? I first want us first to, to think about it. Which one do you think is the heating cave for a candle wax? Now, of course, you know that a candle wax will first melt, will turn it from solid to liquid. That's all. Then again, turn into solid. Of course, when you burn, like when you heat a candle wax, it will melt, turn into liquid. Then later on, after some time, it will turn to solid. So you can realize that the change is direct. Okay, the change is what? Is direct. And from there, when I say the change is direct, it's just a direct change. Simple as that. Okay. Again, we can have a situation like this. I'm not saying Y is the final answer. No. We can also have a situation like this where it's not like the melting is straightforward as you think. No. Alright. It's not as compared to pure ice. Pure ice, okay, will melt and will go direct to liquid. Simple as that. But for a waxy, in as much as it is going direct from so for waxy, of course, it's going direct to liquid, right? But there are other states here which might occur in terms of a waxy. So therefore, the change is not that symmetrical as compared to the ice one. For the ice one, the change is direct. It's just ice, and it's pure, by the way. You got that liquid, and so that means we are having a symmetrical curve of this nature. So this one is for pure ice. But this one, the change may not be uniform, but of course you are going to reach where you want, but the change is not uniform. So that is for a work C. So candle for work C, curve X. All right, I think I've also given this one. I said when the wax is melting, right, in as much as it absorbs heat, all right, there is no that much change in temperature. Okay, there is not that much change in temperature until maybe it turns into a liquid. After that, again, it turns into something else. So the temperature keeps on like rising, dropping, rising, dropping, rising, dropping. You get the concept, huh? This is why we're having here. The temperature is rising, dropping, rising, dropping, rising, just like that. Because we don't have a change where like when it absorbs heat, okay, like there will be a direct change in temperature. Nah, it doesn't work like that for a wax. So the reason is that there is no direct change in temperature, okay, when the wax absorbs what? Heat. So because of this, all right, that means gradually, like the temperature does not like just change gradually, like I've been saying. No, it's not like for an ice. An ice, when it just absorbs heat, it will gradually turn into liquid. Simple as that. So there will be that change in temperature, direct, and of course to be a physical change. But for this one, once it absorbs temperature or it absorbs heat, it's not that the change will occur immediately, no, or that there will be a change in temperature immediately. No, it first have to absorb heat, okay? It will keep that heat and it will start first melting slowly by slowly, slowly by slowly. Sometimes it increases, decreases, increases, decreases. So there's no uniform change in temperature, okay? Maybe let me say no uniform. There's no uniform change in temperature, okay, when the wax absorbs the heat. I think this is a perfect reason to give. Of course, we can give other reasons, but based on the graph, I think this one will be valid. All right, thank you so much. And I hope that you enjoyed one or two things from here. We keep on learning. Learning does not end. And these are not the final answers. There can always there can always be a number of explanations. So don't just depend on my answers. Google, research, and so on. I wish you lucky, and I'll see you next.